Alright, this is Catastrophe problem 2.16. Again, we are up on the top of a building, and this building is 10 meters high. There's two cats up here. There's one cat that's dropped, falls all the way to the ground, and when this cat is halfway down, right here, 5 meters down, when this cat gets right to here, another cat, this first cat's dropped from rest, but when the cat gets to here, the other cat is thrown down from here and hits the ground at the exact same time this other cat does, which means this cat gets all the way to the ground. The time it takes for this cat to get all the way to the ground is the same amount of time that it takes for the cat to get from here down to the ground. So all we need to do is figure out how much time it takes to get from here to here, and then we can work backwards to figure out what is the initial velocity of this particular cat right up here. Okay, so this cat falls from rest, so we can use d equals VIT, but initial velocity is 0, so we'll just do d equals 1/2 AT squared. And if we solve for t, we would get 2d over a, which is gravity, which is negative 9.81, and it'd be the square root of that. So what I want to do first is I want to figure out how much time it takes to get the cat to get from here all the way down to the bottom, and that would be falling 10 meters. So that'd be the square root of 2 times 10, or 20, divided, or it'd be negative 20 because we're going down. Negative 20 divided by negative 9.81, and that gives me a time of 1.428. Then I want to figure out how far does it take it to fall just from here down to here, the first 5 meters. So that would be the square root of negative 10, be negative 5 times 2, negative 10, divided by negative 9.81. And that gives me a time period of approximately 1.010. If I subtract those two times, I'm going to get this time right here, which would be this time right here. That's going to be helpful. So I get 0.418 is my total time there. So now I can come back up and I can use this equation. I can use, well, I'll use this equation up here, but this time I need VIT also in there. And so the total distance that we fell is negative 10, and that would equal 1/2 let's see, 1/2 A, so that'd be negative 9.81 times t squared, 0.418 squared, plus VI, which we don't know, times the time, 0.418. And we'll try to solve that problem. And you should get a velocity, I think, of like around negative 21.7, I believe. Yes, I paused my work and I checked it, and that was the answer. It was actually, I got like negative 21.8 meters per second is how fast that second cat is thrown down with initial velocity, so it hits the ground the same time that this cat here was dropped. So hopefully you have a good grasp of that problem.